Hello there, math fans. I'm Dr. Andy Lovelace. I'm a longtime 20-year professor from the University of Washington. I've taught over 20,000 students. I'm going to make a video series on the number pi and the constant pi. When I was growing up, there was no such thing as Pi Day. I only learned about it a few years ago. I hear that students celebrate it in elementary, middle, and high school. I was talking to a collection of 20-year-old college students in my office hours the other day, and they were talking about their Pi Day and all the years of celebrating it. And I said, well, do you guys know what pi is? And they said, well, we know it comes up in the area of a circle, but we have no idea where it comes from. And so I thought, well, if we're going to celebrate Pi Day, maybe I can give a little info so that everyone should know what it is. Of course, if the goal is to eat pie, then you don't need a reason. That's more important than anything you'll see here. But I'm going to make a series of videos about what it is, many examples from my life. I'm going to try to start people on Pi Day. I really would like everyone to measure the diameter and circumference of a circle and post it online. So this would be the Pi Day challenge I hope to start. So I'm going to start this initiative. And then I'll talk about history and gaining accuracy and give some background. I did a similar thing for the number E, and several students said they liked that. I'll prove the area of a circle in several different ways and show you why the number pi pops up. I'll do the area of arc length around the edge of a circle and how in the area of a wedge of a circle. Many people don't know the formula for how you'd find the area of a piece of pizza. So I will explain that. And then I'll explain why we really like radians, especially in calculus. We start to really see it when we talk about arc length and wedge area. And then I'll talk about angular and linear speed. There's some interesting things there. So I have a sequence of whatever it is, 4 or 5 videos I'll probably make over several weeks. I'm sure I won't have these up by Pi Day because I have my own courses to teach and finish up. And then I'm sure I'll think of more things. Anyways, if you look around your house, it won't take you long to find many circles. I've been finding them like crazy, as you will see in the video that follows this. But I just thought I would start with a very brief intro, and then that'll be the end of this video. Some of the future videos will be longer, but for now I'm just going to get some things up here. So imagine you have a circle. There is a rough circle I've drawn on here. And imagine you go all the way across it. We call that the diameter. So there's the diameter of our circle. Imagine you walk across there. So let's put a little person on here. We're going to go for a walk. Oh, I lost my color. We're going to walk from here to here. And we'll measure how long that is. At the same time, imagine our friend goes for a walk, but they go around the outer edge. They're going to have to go further, but let's assume they keep walking all the way around. And we would like to compare the distances. And it turns out it doesn't matter how big or small the circle is, there's something that's fundamentally always true, and it's been observed for a long time, as I'll talk about in history. This is something many people have seen, but it's really valuable when you're constructing things or knowing this fact. Okay, so the question is, I've copied and pasted this a few times. There's the diameter again. Imagine I could take, and you can do this yourself, get a little piece of string, measure across, and think about how many strings of that length you could lay around the outside. And I would have you estimate if you were here. And just let them walk and see. Okay, I'm going to show you. I've done this. I've laid out the string, and then I put it in a grapher. And this is going to be part of some of my future videos, but I'm hiding our result here. So I'm going to shrink my fat head down a little bit. And here we go. So there you go. I've laid the purple one out, the purple piece of string, that first diameter, and I made it right here. And there's an interesting fact that I think a lot of students that know a lot of calculus don't know, which is that first angle, you could figure out what it is when you've traveled one diameter. And it turns out it's 2 radians. but that's a story for another day. Okay, so then what do? Then we do it again. In this example, the radius was, the diameter was 10. So this was 10. Let's just say feet. We walked 10 feet from here to here. Great. And then we're going to go again. This is 10 feet. And interestingly, again, you don't need to know anything about the angles to watch this video. This is for later, but that's another 2 radians. Radians really connect the diameter to the edge length very well, which is why we like radians so much in calculus. Okay, if you keep going 10 more feet around the edge. It's hard to measure around the edge. As I've been making these videos, I'm realizing as I do examples, you basically need a string and then you straighten it out. We don't quite make it there in 3. But the amazing thing is it doesn't matter if the circle is gigantic. It doesn't matter if it's the Seattle Great Wheel or if it's just the lid of a container. It's this ratio we're talking about. So we fall short. Don't quite make it there in 3. How much more do we need? Well, we need about 14% more, or 0.1415, this weird number. So we need to go about 14% of the way. Think about what 14% of this is. Grab this, plop it on here, and say, okay, about 14% of that. That's how much we need to go that last little bit. So it's 3 and a bit. That's it. That's what pi is. And the observation is it's always the same number. So somebody said, well, let's just write it down and then we can use it in the future. For a long time, people just use 3, but you can see it's a little bit short. So that's it. I will follow up this video with several examples from my life, just measurements. It's kind of, we're going to discover pi. Pretend we just saw this for the first time, and I'm going to do so many measurements. And my hope is you'll do a bunch. And at some point we'll be like, okay, I think we believe this, but I'd like to overwhelm us with measurements, fun measurements, before I actually get into the history. All right. Thanks for listening.